So with that, let me go ahead and get us started. Oh, we're up to 51 now. Doing great. I'm going to start sharing my screen, and just to be able to share with you the videos we'll be looking at. As I said, Catherine Hayhoe is quite busy right now. She is now the new chief scientist for the Nature Conservancy, as well as having major roles in the upcoming COP26, the Conference of the Parties conference in Glasgow. So she's not taking any additional speaking engagements at this time. So what we're going to be doing is sharing with you as a whole aspect of this buffet concept and the trying to provide resources. We're going to be going over some of these great global weirding videos that she has recorded and made available online. And with those, you'll have an opportunity to take them back to your congregations and be able to show folks what's available in those. Catherine Hayhoe, of course, is a renowned atmospheric scientist and professor of political science at Texas Tech University. She is also an evangelical Christian married to an evangelical pastor in Lubbock, Texas. So she is someone who has literally written the book on climate change and speaking to congregations about climate change. So with no further ado, I'll go ahead and start introducing this. The presentation and the Q&A at the end will be by Colin Evans of Cornell University and myself. Colin, I'll let you go ahead and introduce yourself to everyone.
Great, thank you, Mark. So yeah, hi everybody. My name is Colin Evans, and this fall, I'll be starting my 5th year in a PhD program at Cornell, studying atmospheric science, where my primary focus of research is in drought dynamics in the Northeast, where I am, and also in the Southwest, but more broadly, climate change in general. I got my undergraduate degree from Wells College in 2012 in environmental studies, and my master's at the University of Massachusetts Lowell in atmospheric science in 2015. And like I said, this is my 5th year at Cornell, so I've been there since 2017.
Thanks, Colin. Glad to have you with us, and he'll be a great resource for answering a lot of the questions about the atmospheric side of climate change and its impacts on the land, especially through drought. I'm Mark Eakin. I'm now a retired oceanographer from NOAA. I was working for NOAA for about 30 years. Most recently running the program called Coral Reef Watch that looks at the impact of climate change on coral reefs around the world. Prior to that, I also managed programs in NOAA on paleoclimatology and on climate dynamics and experimental prediction through the Climate Global Change program of NOAA. Also, I'll put in a little plug for something we're not actively doing anything on at this conference, but for those of you who were at the last one, we did a screening of the film Chasing Coral. I serve as the chief scientific advisor for the film Chasing Coral that is available on Netflix. So I encourage you all to go and check that out. The global weirding videos are a wonderful resource. In looking around and figuring out how to get the word out to as wide an audience as possible, and especially to an audience that may not necessarily understand climate change or agree with climate change, Catherine took an opportunity to work with a local public broadcasting station there in Texas and developed a series of videos, short videos that range from 5 to 10 minutes in length, most of them being 8 or 9 minutes long, and did this over the course of 3 seasons. These 36 episodes in total are available online. I'll post these links in the chat, but the easiest thing to remember is to just Google global weirding to get the web pages on both PBS and YouTube where you can find all of these videos. What we'll be doing today is going through and showing a few of these that'll give you an idea of what's going on in these videos, give you a bit of a taste of different parts of it. And at the end, we'll be going through and answering your questions. So as I say, please enter your questions in the chat. At this point, what I'm going to do, let's see, let me double check something. I'm going to stop share for just a moment to make sure that the screen sharing is, yeah, there we go. It has the sound on. All right, so we'll be showing the videos, and we'll come back to the Q&A after we've done this. So the first of these, what's the big deal with a few degrees?
A few degrees is no big deal. Outside, temperature can go up and down by that much in a single hour, right? So why are scientists so worked up about such a little change? It's true, a degree or two does not sound like a lot of global warming. So when we hear that the Paris Agreement wants to limit warming below 2 degrees Celsius, or that the latest report from the Intergovernmental Panel on Climate Change, or the IPCC, says that the impacts will be very serious even past 1.5 degrees, it just doesn't compute for most of us. In our lives, over the course of a single day, temperature goes up and down all the time, by a lot more than 1 or 2 degrees. So what's the big deal? Here's the difference. We aren't talking about the temperature of a certain place at a certain time. We are talking about the long-term average temperature of the entire planet, which over human timescales is as stable as that of the human body. Think about your body. It's pretty warm to begin with, 37 degrees Celsius or 98 Fahrenheit. Then imagine it goes up a degree Celsius or nearly 2 degrees Fahrenheit, as the temperature of the Earth already has. That's worrisome. It's not normal. You start to feel it. You're overheated, achy, tired. You go to the doctor. The doctor says, yes, you are running a fever. And it's not just some illness you picked up somewhere. No, your doctor says, and they add they've consulted with nearly every other doctor in the world, and they agree too. This fever is the result of your lifestyle choices. This is exactly what's happening with the Earth. We are running a fever. And as we talk about in the Global Weirding episode on natural cycles, none of the usual suspects are responsible this time. It's not the sun, it's not volcanoes, and it's not the Earth's orbit. It's our lifestyle choices. Specifically, burning coal and gas and oil, that's about 3/4 of the problem. And the other quarter is deforestation and agriculture. To change the temperature of the planet by a full degree, it takes a lot of energy. And that's why we scientists don't only use degrees, we also use joules. A joule is a measure of energy. It takes 1 joule to lift an apple about 3 feet in the air. You can thank Isaac Newton for that. So how many extra joules worth of energy has the planet accumulated thanks to our lifestyle choices and all the fossil fuels that we've burned? More than 250 sextillion or zettajoules. That is 21 extra zeros. And that number is climbing at a rate of 4 Hiroshima bombs worth of energy per second. Let that sink in. So you can see why this fever is worrying, and why even past 1.5 degrees Celsius or 2.7 degrees Fahrenheit, the impacts are serious. Nearly every way that climate change affects us scales to some degree with global temperature. Average precipitation in some regions doesn't, and we don't know enough yet about severe weather events like tornadoes and hail to say for sure how they're changing. But just about everything else, heat waves, heavy precipitation events, the area burned by wildfire, coastal flooding, even economic costs, all of those tick up as the mercury rises. So the more carbon we produce, the greater the temperature change that we'll see, and the greater the damages. Just like the impacts of a prolonged high fever on the human body. Let's look at economic costs first. If the world warms by 2 degrees, the average GDP of many poor countries would drop by 5 to 10%. If the world warmed by 4 degrees, it would be more like 10 to 25%, with a global average around 20%. In the US, many regions, particularly the Southeast and the South Central region, could see drops of up to 20% in their GDP as well. How about human lives? Burning fossil fuels is already responsible for air pollution that kills over 4 million people around the world every year, 200,000 of those in the United States alone. But warmer temperatures make that pollution worse. It's estimated that if the world warms by 2 degrees rather than 1.5, that would mean an additional 150 million deaths just due to air pollution alone. The difference between a warming of 1 or 2 or 3 degrees or more is laid out in detail in a few key resources. First, there's a report by the National Academy of Sciences called Climate Stabilization Targets. In this report, which I co-authored along with other scientists, we found that per degree of warming, we expect a 3 to 10% increase in the amount of rain falling in the heaviest events, a 5 to 15% reduction in the yields of major crops, and a 200 to 400% increase in the area burned by wildfire across the western US. And as we talk about in our Global Weirding episode on climate impacts in the Southwest, the area burned by wildfires today has already almost doubled since the 1980s due to a changing climate. Then there's the 2018 IPCC report that looks at the difference between a 1.5 and a 2 degree world. It highlights not only the risks that increase with temperature, but also which ones we'd see a significant difference in, even between 1.5 and 2 degrees. These include average and extreme temperatures, sea level rise, extreme rainfall, and drought risk for some regions. It's estimated that biodiversity loss could double under an additional 0.5 degree of warming, and there would be increased risk of permafrost thaw in the Arctic, as well as ocean acidification around the world. In terms of human impacts, if warming can be limited to 1.5 instead of 2 degrees, this could mean 50% fewer people exposed to water stress, and lower risks to health, food security, and economic growth. That's a huge difference we're talking about for just 0.5 degree Celsius or 0.9 degrees Fahrenheit of global warming. So how do we connect the dots between global change and what it means right here in the places where we live? That's actually what I do. I do that by combining real-world data with climate model outputs and using that to calculate how our lives will be affected as the world warms by 1 or 2 degrees or more. We calculate the impacts on things that matter to us, like corn yields in Iowa under a 1 versus a 2 or 3 degree warming scenario. How often a record-breaking hot summer, like the one we saw in Texas in 2011, would recur as the world warms by 1 or 2 degrees. Or how the water supply for a city or a water district or a state would be threatened as the world warms by 2 or 4 degrees. Why do I do this? Because in order to understand why another degree of warming is such a big deal, we can't rely on our own experience of temperature. None of us has ever experienced such a big change in global average temperature, and especially not one that's happening so fast. As far back as we can go in the history of human civilization on this planet, we have never lived through such a large and a rapid change. It truly is unprecedented. And our food, our water, our energy, our infrastructure, and our economic systems are not built or prepared to cope with it. So next time someone scoffs, 2 degrees, that's nothing. Tell them, no, it is a lot. It is more than enough to tell us that our planet is running a fever. It's real, it's us, and it's not just serious. It's time to fix it before it's too late. Thanks for watching Global Weirding. This episode was brought to you in part by Citizens Climate Lobby. If you have any questions about climate versus weather, Let us know during one of our Facebook Live Q&As. And please be sure to check out globalweirdingseries.com for more episodes. See you next time.
So now we'll jump into another one. She was just introducing the idea of what the difference is between climate and weather. So let's let Catherine talk a little bit about that.
It's freezing outside, so clearly all that global warming is a bunch of hooey, right? Winter or summer, the temperature of the planet is ticking steadily upwards. Since 1900, the planet has warmed by 1 full degree Celsius, or 1.7 degrees Fahrenheit. And each of the last 5 decades has been successively warmer than the decade before. Yet, every time a snowstorm hits, it seems like we hear at least one politician or media pundit trot out the old chestnut. Global warming, global cooling more like, my car just got buried under 3 feet of snow. But just because it's cold in winter doesn't mean the entire planet isn't warming over climate timescales. Let me explain. We have seasons on our planet because the axis of our Earth's rotation is not straight up and down. It's tilted 23.5 degrees as it orbits around the sun. In winter, our hemisphere tilts away from the sun, which reduces the amount of energy we receive and makes it colder. In summer, we tilt towards the sun, which gives us more energy and makes it warmer. Will global warming affect the tilt of the Earth? Not really, but interestingly, it turns out that as our massive ice sheets in Greenland and Antarctica melt, the weight of all that water going into the ocean is causing the Earth to wobble just a teeniest bit on its axis. But does this mean the end of the seasons? No, of course not. The Earth will still be tilted, and all the seasons, winter, spring, summer, fall, will continue to exist even as the planet warms. They'll just look and feel different than they have in the past. How are our seasons changing? Well, first of all, they are getting warmer. Yes, even winter. In many places today, what we would consider to be a cold winter would have just been an average winter a few decades ago. Then, summer weather is arriving earlier and it's lasting longer. Summers are hotter, with longer and more frequent heat waves, and extended growing seasons and wildfire seasons. Okay, you might say. So that's why we still have winter. But what about today? It's freezing. To answer this one, we need to understand the difference between weather versus climate. Weather is what happens in a certain place at a certain time. Climate is the long-term average of weather over at least 20 to 30 years. While the weather might fluctuate from day to day, climate is the long-term average. So that one cold, snowy day or even week, that's weather. Global warming or not, we still get cold days, especially in winter. In fact, did you know that we actually break all kinds of cold temperature records every year? That's right. 10,632 of them in the US alone in 2017 to be exact. And when climate isn't changing, we break about the same number of hot temperature records. Since 2000 though, more than twice as many hot temperature records are being set on average as cold ones. In 2017, for example, the same year that we broke over 10,000 cold temperature records, we also broke 36,305 high temperature records. That's more than 3 times as many high temperature records as low ones. Any individual record, hot or cold, that's weather. But we're setting far more hot ones now than we were 30 or 50 years ago. The ratio is changing, and that's climate. It's pretty straightforward to connect extreme heat to a warming planet, but there is some funky stuff happening in other seasons too. Can you believe that warmer temperatures can actually increase the amount of snow that falls sometimes? That's right. As temperature warms, the air can hold more water vapor. When a storm comes along, there's more of it for that storm to sweep up and dump on us. If it's cold enough, all that water falls as, you guessed it, snow. And some of the biggest increases in heavy precipitation that we've seen the last few decades have been on the East Coast. So ironically, some of the very storms that the pundits and politicians have used to argue that the planet isn't warming are actually consistent with the fact that it is. Another cutting-edge research topic these days is what's happening in the Arctic. There's some indication that the record warm temperatures we've seen in recent winters in the Arctic may be opening the freezer door, so to speak, letting Arctic air spill down over the mid-latitudes, where, although it might be balmy by Arctic standards, is freezing for us. We talk more about that in our global weirding episode called What Happens in the Arctic Doesn't Really Matter, right? When it comes to climate and weather, though, there's one more common myth out there, and it goes something like this. You scientists can hardly predict the weather 3 days from now, but you expect us to believe you can tell us what's going to happen in 30 years? Predicting the weather is a tough gig. Why? Because weather is a chaotic system. It depends critically on initial conditions, and we're not able to observe and model those conditions in anywhere near enough detail to be 100% accurate all the time. However, weather forecasting is always getting better, thanks to the satellites, ocean buoys, and high-tech models that scientists are creating and using around the world. And the models we use for weather prediction are actually based on the exact same physics as climate models. But climate models have it a bit easier. They don't have to tell us what's going to happen at a specific place at a certain time. Instead, we use them to simulate the long-term statistics of weather and how they're affected by what we call external factors, like changes in energy from the sun, volcanic eruptions, and yes, human activities. Climate models give projections of what's going to happen decade by decade into the future, over timescales where the uncertainty due to natural variability mostly averages out. So the biggest uncertainties in climate projections long term, the first one is trying to figure out how the planet's going to respond to this unprecedented experiment we're conducting in terms of all the carbon dioxide and heat-trapping gases that we're pumping into the atmosphere faster than any time we know of, even in the distant past. The second big uncertainty are the choices that we humans make that will determine future emissions and future change. So we can't predict what the weather's going to be like on June 18, 2064, but we can say with confidence that the planet is warming over climate timescales, and the more fossil fuels we burn, the bigger and the faster the changes we'll see. Thanks for watching Global Weirding. This episode was
That brings us to some of the things that we've seen in recent years. Now, the video we're about to watch, all the extreme weather we've had lately isn't anything new, right? Could have been written today. Actually, you'll find the examples are a little dated, and there have been some more extreme weather conditions we've been seeing this year than some of the things that Catherine talks about from this video that was originally posted in 2016.
crazy weather. We see it all the time. Here in Texas, we get it. Hail and haboobs, blizzards and heat waves, tornadoes and tropical storms. So there's been a lot of extreme weather in the news lately. That doesn't mean anything's different, right? Over the course of human civilization, the Earth's global average temperature has been about as stable as that of the human body. Sure, it's gone up and down from year to year, and there was a medieval warm period in Northern Europe, but not the rest of the world. And there was a little ice age too. But these were really minor changes compared to what we're seeing now. Today, our planet is running a fever. It's a fever that climate scientists, the physicians of the planet, can measure using thousands of thermometers all around the world. But it's also a fever that has all kinds of crazy symptoms. If you live in the Midwest or the Northeast United States, you've seen a big increase in heavy rain and even snow events because evaporation happens faster when it's warmer. So along comes a storm, And there's a lot more water vapor sitting up there in the atmosphere for that storm to pick up and dump on us than there would have been 50 or 100 years ago. In Minnesota, flood insurance rates haven't just doubled, they've tripled over the last 20 years. And a few years ago, Farmers Insurance even sued the city of Chicago for failing to adequately plan for the impacts of a changing climate, leaving insurance companies to pick up the tab. What if you live in the Southwest United States? There, you've got the opposite problem. Faster evaporation there is drying out the soil and the lakes and the reservoirs. So when the droughts come, as they always do, they're getting stronger and they're lasting longer. And in the West, higher temperatures and earlier snowmelt mean that forests face longer wildfire seasons. Today, the wildfire season is 7 months long, compared to the 5 months that the typical season lasted back when I was born in the 1970s. In many cities around the world, heat waves are a big concern. Thanks to all the asphalt and the tall buildings with dark roofs that soak up the sunlight, cities are already a lot warmer than their surroundings. This was discovered by a British doctor nearly 200 years ago. It's called the urban heat island effect. Add that urban heat island effect to the increased risk of longer and stronger heat waves, and we have a problem, a big one. One that can send hundreds and even thousands of people to the hospital, heat that can melt roads, warp rail lines, and overload our electricity grid, giving us brownouts and even blackouts just when we need our air conditioning the most. What if you live along the coast? Well, there we've got sea level rising and future hurricanes getting stronger as the ocean warms, feeding them more energy. In Louisiana, rising sea level and sinking land has already created America's first climate refugees, forcing native tribes on a barrier island to resettle elsewhere as their homes began to disappear into the sea. Cities, water treatment plants, vacation homes along the coast are even more at risk now than they were when they were built. Take the south end of the old port city of Portsmouth, New Hampshire. People who live in a low-lying area of the city should consider selling their house, and I'm not kidding, says my colleague Cameron Wake. He's a professor at the University of New Hampshire, and he knows what's happening in his local area. He says, if there's another big coastal storm like Hurricane Sandy, those houses are at risk of flooding today, and it won't get any better in the years to come as sea levels continue to rise. His recommendation may be difficult to swallow. He says, why deal with the headache? Sell now while you can still get money out of the home. The same principle applies to many other investments. Farms and ranches in areas that are projected to run out of water. Low elevation homes in the Florida Keys or coastal Miami, where sea levels are also rising and hurricanes are a constant risk. Or a vacation cabin at a ski area already struggling to keep their winter snow. 9 times out of 10, or maybe even 99 times out of 100, climate change isn't creating some exotic new problem that we've never seen before, like plagues of locusts or scary new diseases we can't pronounce. Most of the time, climate change is hitting us in our Achilles heel, right where we're already vulnerable to naturally occurring weather and climate extremes today. Climate change is just giving them steroids, making them worse. What does it look like to prepare for a changing climate? All we have to do is look around where we live. What types of weather events have already hit us hard over the years while we've been living there? The jury's still out for some of these. We don't know yet how tornadoes or supercell thunderstorms or crazy straight line winds are affected by climate change. But we do know that their risks aren't going away anytime soon. And as for the rest, well, chances are climate change is making many of them worse. Heat waves, droughts, floods, hurricanes, winter storms. That's why it makes so much sense to prepare, to build our resilience to the risks that we already face today and the even bigger ones we're going to see tomorrow, thanks to climate change. Thank you for watching.
So now we've seen a bit about what's happening on a large scale. Let's get into one region. Catherine has a whole series of these videos that are regionally focused, talking about what's going on in certain parts of the United States and how climate change is influencing those regions. We decided to go ahead and go with the Eastern US based on some of the registration information we had coming in, but for most areas in the US, you can find a video that matches what your area is going to be going through.
Climate change isn't just an issue for future generations anymore, or for people or animals who live far away. It's already affecting us right here in the places where we live. And the more climate changes, the bigger the impacts we'll see. If you live in New England or the Northeast, you're used to having 4 very distinct seasons: cold, snowy winters, blustery springs, green summers, and colorful falls. But we are already seeing these seasons start to become muddled. Winters are milder, spring is coming earlier, and warming temperatures are changing many of the very things that make the region so unique. Leaf peeping, as they call it, is a multi-billion-dollar tourist attraction, but the peak season is shifting to earlier in the year. And as the mix of trees changes, the colors may not be as spectacular. In the Adirondacks alone, tourism brings in about $1.5 billion a year. But as the lakes get warmer, more algae grows. And lakes filled with green goop aren't exactly fun to swim or boat in. And warmer winters means less snow and ice for skiing and snowmobiling and ice fishing. In Maine alone, snowmobiling brings in over $200 million a year and provides over 3,000 jobs. But the warm winter of 2016 hit hard, and drops like this can be devastating for the economies of many rural communities. Cold winters also keep pests at bay. As winters are warming, ticks are moving north. Some of these are spreading Lyme disease across the region. Others, like winter ticks, don't carry disease, but they do suck blood. Winter ticks are currently killing about 70% of the moose calves born in New Hampshire, according to the state's Department of Fish and Game. One poor moose calf had nearly 100,000 ticks on him when he was found dead recently. The Northeast also has a lot of big cities. Most of these are already covered in concrete, and they don't have a lot of vegetation. This means they get even hotter during extreme heat events, thanks to something called the urban heat island effect. And this affects our health, increasing the risk of sickness and even death, as extreme heat disproportionately affects the very old, the very young, and those suffering from respiratory or cardiovascular disease. Cities with their paved surfaces are also more at risk of flooding, and the risk of the historical 1% heaviest precipitation events across the Northeast has already increased by 55%. It isn't just about what's going on land. The region's coasts support all kinds of fishing and aquaculture businesses, as well as tourism. As sea level rises, the ocean warms, and ocean acidification continues, these are all under threat. Now, the Gulf of Maine is warming faster than most ocean areas, and that is affecting the shellfish and the lobster industry. On the north end, in Maine, lobster harvests are actually booming, as the water has warmed to the ideal temperature for the crustaceans. But south of Cape Cod, the harvests are already collapsing, as the water warms above the level where lobsters can thrive. And experts worry that this collapse could move north as ocean waters continue to warm. And then there's the fact that sea level rise is exacerbating storms, contributing to higher surges that extend further inland, as we saw during Superstorm Sandy in 2012. If you live in the Southeast, you already know what a hot, humid summer looks like. But the bad news is these summers are getting even worse thanks to climate change. One study looking at the economic impacts of climate change across the US found that counties that are already economically disadvantaged, including much of the Southeast, could experience a 10 to more than 20% drop in their GDP as a result of a changing climate. That's because of impacts on crop yields and the fact that hot, muggy conditions during summer could lead to over 500 million lost labor hours in the Southeast alone by end of century, affecting many people's jobs, especially in the smaller rural communities that need them most. It doesn't help that warmer summers and longer, more intense droughts will also affect water supply and increase wildfire risk. Rising temperatures and more extreme rainfall exacerbate problems like vector-borne disease, water contamination, and poor air quality. Across the US, an average of 200,000 people die every year from air pollution, many of those in the southeast. And the warmer it gets, the worse our air quality gets. As winters warm, tropical and subtropical species are moving north, both on land and in the water. Southeast residents already know what invasive species look like. Kudzu, which was originally planted by farmers in the first half of the 20th century, is known as the vine that ate the South. The estimated costs of dealing with it range from about 50 million to almost $500 million per year. Palmer amaranth, known as the superweed, is taking over entire fields of corn and soybean and cotton, major crops in the South. In the warming Gulf of Mexico, a flesh-eating bacteria called Vibrio vulnificus is causing greater infections in humans and becoming a problem earlier in the year. Then there's the coastline, where yes, the sea level is rising. A lot of people live along the coast. It's home to major cities from New Orleans to Norfolk. Sunny day flooding, when roads, buildings, even parking garages flood, even though there's no storm, is happening more and more. This is already affecting property values in coastal cities like Miami, where property prices for homes that are vulnerable to sea level rise have already dropped an average of 7% relative to their neighbors just a few blocks inland. If we don't do anything about it, high tide flooding throughout the southern states could be a daily occurrence by the end of the century. This would put hundreds of billions of dollars of infrastructure at risk, not to mention most of the Florida Keys and many iconic locations, from historical St. Augustine to the NASA Kennedy Space Center in Cape Canaveral. And I haven't even mentioned the increased risk of flooding due to heavier rainfall, from normal storms as well as hurricanes. One of the biggest ways climate change affects you if you live in the Southeast is by amping up the amount of rainfall associated with any given storm or hurricane. Hurricanes aren't getting more frequent, as we discussed in our Global Weirding episode on hurricanes, but as the planet warms, we are seeing bigger, stronger storms that intensify faster and that move much more slowly, so they can spend more time dumping their rain on us once they hit. The bottom line is we care about a changing climate because it's loading the dice against us. It's taking many of our naturally occurring risks and our pre-existing vulnerabilities, and it's making them worse in ways that affect us directly here and now. I live in West Texas, where the roads are long and straight. So straight that if you really wanted to, you could drive down the highway just looking in the rearview mirror. Until that is, you hit a curve in the road. If you are not looking up ahead, you'll miss the curve and boom, you're off the road. What does this have to do with climate? The same principle applies. The information that we use to plan for our future is crucial. If we're relying on historical climate averages to determine future risks, we'll end up far from where we want it to be, unprepared for intense rainfall, record heat waves, or rising seas up ahead. No matter where we live, we're on the curve today. And what can we do about it? We need to prepare, to build resilience to the risks that we can't avoid, and, as I discussed in many other Global Weirding episodes, to reduce our emissions of heat-trapping gases to avoid the risks that we can. The U.S. National Climate Assessment is one important resource that helps us look ahead down that road. Please check out nca2018.globalchange.gov for more valuable information on how climate is changing in the places where you live and what we can do to prepare.
So now, having seen a little bit about how climate is changing, let's think about it from the perspective of the fact that we're Presbyterians. We're not just here on an environmental conference. This is to learn about how we can share in the work to protect creation. So some of the videos that Catherine has addresses this, and this one is entitled "Religion Has Nothing to Say About Climate Change," right?
In June 2015, the Pope issued a formal report called an encyclical on climate change. Some were puzzled. He's not a scientist, they said. Why is a religious leader weighing in on climate change? Climate change isn't just a scientific issue. It is also a question of right and wrong. And for more than 80% of us around the world, we often get our sense of what is right and wrong from our faith. That's why leaders from across the entire spectrum have issued statements on climate change and on the importance of caring for creation and for other people on this planet. Informed by our science, it's our hearts that tell us we must act. I'm a scientist, and as a scientist, I can tell you science is awesome, but it can't do everything. When it comes to climate change, here's what science can tell us: that climate is changing. Science can also tell us that for the first time in history, humans, not natural cycles, not the sun, are the main cause of this change. Science can also tell us that the choices we make going forward will shape our climate future. If we continue to depend on old, dirty, polluting fossil fuels for most of our energy, we're going to be following a much higher and faster pathway to change. On the other hand, if we can transition in a sensible, sustainable way to clean sources of renewable energy that don't produce heat-trapping gases and other pollution, we're going to be heading much more slowly towards a safer future that will be easier to prepare for. Science can tell us what's likely to happen to our food, our water resources, our health, even our economy, depending on how much fossil fuels we burn. But this is where the science stops. Science can't tell us what's the right thing to do. Should we put a price on carbon? Or should we cap emissions and allow polluters to trade? If so, how much and how fast? Should we shut down the fossil fuel industry or encourage it to transition as well? Invest in new technology or help poor countries to adapt? Ideally, all of the above, but practically we can't do it all. We have some tough choices to make. And for that, we need to engage our hearts. And for many of us here in North America and around the world, what's in our hearts has a lot to do with our faith. Faith and science are not in competition. They are not two alternate and mutually exclusive systems of belief. As one atheist put it, scientists do not join hands every Sunday and sing, "Yes, gravity is real, I will have faith." In the same way, sacred texts like the Bible, the Torah, the Quran, they're not science textbooks. These books are intended to serve as guides, giving us a perspective on where we came from, where we're going, and how to live our lives here and now. That's why we need our science and our values when it comes to difficult, thorny issues like climate change. Speaking for myself, I'm a Christian, and I believe that as a Christian, I'm called to help people who are suffering. Who's most vulnerable to the impacts of a changing climate? The poor, the world over. From the single mother in McAllen, Texas, who can't afford to keep her family's apartment cool as the summers get hotter, to an elderly fisherman in the Maldives, who will soon have to find a new place to live as sea level rises, to the Syrian family in the refugee camp, their land and their home long gone, desperate to just find a safe place to live. But here's the good news when it comes to climate change. The desire to care for and help others is not exclusive to any one denomination or religion or even faith. Atheists, agnostics, and humanists share these values too. How do I know? Because when it comes to making statements about climate change, it's not just the Pope. Nearly every major Christian denomination and world religion has something to say about it. From the Episcopal Church, they say, "We are painfully aware that those of us living in the Northern Hemisphere are responsible for the majority of climate change. Accordingly, we hold a particular responsibility for the changes that will reverse the trajectory of atmospheric warming and safeguard the sanctity of what our God calls very good." From the other side of the world, here's part of the Hindu Declaration on Climate Change. We must consider the effect of our actions, not just on ourselves and those humans around us, but on all beings. We have a dharmic duty for each of us to do our part in ensuring that we have a functioning, abundant, and bountiful planet. There's even an Islamic declaration on global climate change. Our species, though selected to be a caretaker or steward of the earth, has been the cause of such corruption and devastation on it that we are in danger of ending life as we know it on our planet. This current rate of climate change cannot be sustained, and the Earth's fine equilibrium may soon be lost. Faith and science, data and sacred texts. On climate change, they're painting the same picture. Unless we've signed up for that trip to Mars, This is the only planet we have. It just makes sense to care for it, and to care for our brothers and sisters who share it with us, particularly those who are less fortunate than us and who are already suffering the impacts of a warming world. I truly believe that just about every single one of us, no matter our religious background or lack thereof, we have all the values we need to care about climate change built into us. Every human on this planet is born with a sense of responsibility, appreciation for our world, and often an instinct to care for others too. And that's exactly what we need to make good choices and to inform our actions on climate change today. As scientist Jane Goodall says, it's only when our clever brain and our human heart work together in harmony that we can achieve our true potential. Thank you for watching.
And of course, that's the reason why the General Assembly passed the statement, the white paper on power to change that was discussed in part as a part of the grants that are being made available through Presbyterian Investment and Loan. One last video, thinking about that, taking into consideration what we can do as individuals and as groups. We'll close with, I'm just one person, what can I do? And keep the questions coming in. There's some questions that have already come in through the chat.
I'm just one person, and climate change is such a huge, overwhelming problem. No matter how hard I try, and no matter how small I shrink my carbon footprint, it won't make a difference, right? The average American emits about 18 tons of carbon dioxide into the atmosphere each year, and the average Canadian about 16. That's 4 times the global average. To put it in perspective, it's the equivalent of each of us driving a mid-sized car around the entire circumference of the planet one time each year. There are so many climate-friendly steps we can take in our everyday life, and many of them will also save our pocketbooks. The very first step is the easiest and the most painless, I promise. What's your personal carbon footprint? Before you set about making it smaller, you first have to know how big it is and where is all this stuff coming from. Is it your house, your food, your travel? It's different for each of us because it depends on our lifestyle. There's a bunch of cool calculators available online that help you measure this. Just Google carbon calculator and you can find them. Once you know your carbon footprint and you know where it's coming from, then you can start making changes. These could be small things you do around the house, like recycling, washing your clothes in cold water instead of hot water, which uses 5 times the energy, or swapping out old incandescent light bulbs for more efficient LEDs. Making the light bulb switch could cut your emissions from lighting by up to 85%. That's half a ton of carbon emissions every year for your household. And if everyone in America changed just one old incandescent bulb into a new LED, that would be like taking almost 800,000 cars off the road. We can make larger changes, like when it's time, purchasing an Energy Star rated appliance the next time we have to replace our fridge or our washing machine. If every new appliance had that rating, it would be the equivalent of taking about 350,000 cars off the road. Or you could make heating and cooling your home more efficient by caulking your leaky windows and adding insulation to your attic. If your house isn't weatherized, you're likely losing as much energy through air leaks each year as you would if you just left a window open the whole time. Doing something as simple as installing a $50 programmable thermostat could lower your energy bill and your emissions by 15%. As you can see these days, there are a lot of good options. And they also include options for powering your home with renewable energy. You could see if your energy utility offers a green power plan, or you could even have your own solar panels or your own personal little windmill installed on your roof. I live in Texas, and for many parts of the state, buying wind power for your home is just about the same price as getting it from natural gas or coal. There's also a lot we can do in our own diets. That includes eating locally produced foods, not wasting food, opting for tap water over bottled water, and eating lower in the food chain. That means more veggies and less meat. 1 pound of red meat creates about 18 times the amount of emissions as a pound of pasta. We can also look at the way we commute to work. We could consider carpooling, even once a week would help, biking to the office, think of the fitness benefits, or telecommuting to the office 1 day a week. I enjoy working in my pajamas myself. My job involves a lot of business trips though, where I can't wear pajamas. So I try to video conference into meetings when I can. And when air travel is unavoidable, I buy carbon credits to offset my travel. There's a lot of good companies that do this. The organization that I use, for example, is called Climate Stewards. They measure how much carbon my plane trip produced, and then they do things that make up for that same amount, like planting trees and buying efficient cook stoves for families in Ghana and Mexico and Kenya, so they don't have to chop down trees to cook their food. A full quarter of the average American's emissions come from driving. So one major step we can take when the time is right is to buy a fuel-efficient vehicle, whether that means finding a car with the best fuel economy in its class or purchasing a hybrid or an electric vehicle. I drive a small hybrid SUV right now, and more than anything, I would love for my next car to be a Tesla. I hope Elon Musk is watching this. The reality is, we can make the biggest changes when we work together. So if you're serious at reducing the carbon footprint of your community, talk to the people who pay the bills at your work or your church or your school or even your gym or your yoga studio. Encourage them to make smart choices too that save money and improve our quality of life. This could be as simple as encouraging your office to install those sensors that turn out the lights when people aren't there, or encourage the gym to check out treadmills that could be plugged into the building's energy system. Why let all that running go to waste? You could install solar panels on the roof, or you could just paint it white if you live in a hot climate like I do to save on the air conditioning bills. We can all help by taking personal and communal steps to reduce our carbon emissions, and that will do a lot. But realistically, it won't be enough all by itself. Our personal choices control only about 40% of national emissions. And even then, we can't always afford to make the choices that we'd like to. The reality is the government also must act. But in a democracy, that's what it's there for, right? To do what we want it to. So really, the most important thing each of us can do is to let our elected representatives at City Hall, in the state capitol, or in Washington or Ottawa know that we're concerned about global warming, and we want them to address it, from tightening fuel standards to building a clean energy economy. This is a leadership issue, and we don't yet have the ability to make some of the choices that each of us would like to. Now, if this sounds kind of scary, and it might, then I'd encourage you to check out a great organization called Citizens Climate Lobby. They have chapters all over the United States and Canada and around the world, and they're all just regular people helping each other figure out how you write a letter or an email or how you call or visit an elected official to tell them one simple message, that we just need a price on carbon. I think they must be doing something right, because Citizens Climate Lobby's Climate Solutions Caucus in the United States is the only one I know of that has the same number of Republican congressmen and women as it does Democrats. So wherever you are, wherever you're from, we all need to stand up together and make our voices heard. We all live on this planet, we all want a better future, and we're not going to get there if we leave climate change out of the picture. Thank you for watching Global Weirding. Be sure to go to globalweirdingseries.com every other Wednesday so you don't miss the new episode. You can subscribe to our YouTube channel, follow me on Twitter, and check out our Facebook Live discussion every other Thursday after each new episode at 7 p.m. Central. See you next time.
Unfortunately, those new episodes are not coming out at this point, so there's no need for you to subscribe to them. But going to Global Weirding through PBS or going to the YouTube channel and getting a hold of these episodes, as I say, there are 36 of them. These are great resources you can use to help educate yourselves and to educate others in your churches and elsewhere on what's going on with climate change and what we can do about it. So at this point, we do have some questions in the chat. I'm going to stop the sharing. So Colin and I can go through and answer questions. I have one that came in advance from Bill Bowman. It's addressed to me and says, since you've worked in government at NOAA, I was curious about the political aspects of this crisis. And the good news is now that I no longer work for the government, I can answer. Bill Gates has written that we have certain technologies on a small scale, like carbon capture directly from the air, but he says that breakthrough technologies are needed in the next decade or so. What developments seem the most promising? How can federal, state, and local governments promote this innovation? Well, I'll start with the last part of that, and that was something that we actually just heard from Catherine about, which is the need for a system that accounts for an accounting for the carbon that we're putting into the atmosphere. So whether it's a tax and a cap and trade, whether it's a carbon credit program, whatever the terminology is, putting a price on carbon is a very important thing, so that we're actually making it possible financially, economically, to make these kinds of changes. Because if we're going to be able to offset the kind of CO2 releases that are going on in the atmosphere at this point, we need to have the funds to do so. And the best way to do that is by, at the same time, having those producers of CO2 and users of CO2 be paying for that and putting the funds in. And that also puts an incentive in to discourage the increased production of carbon dioxide. This can fund some of the things that are in place. And in fact, there are now some programs where they're using technology to capture CO2 as it directly comes out of smokestacks, or as it removing it from the atmosphere and either pumping it back into the ground, using it for various applications, or otherwise making sure that that CO2 doesn't go into the atmosphere. Colin, any other thoughts on that and how it influences the climate system?
I mean, not at the moment. I think Catherine covered it pretty well.
All right, great, thanks. A question came in from Curtis Basinger, and it really addresses some of the things I deal with coral reefs. Corals have been around for several million years. Within the past several million years, the Earth has been warmer than that of 1900 by 3 to 4 degrees C, and yet corals presumably were doing okay back then. What's different about corals today? So one of the things that's very important here is that saying coral is like saying bird. There's that much variety in corals and that make coral reefs over time. And in fact, not only is it several million years, it's a couple of 100 million years that corals have been around. During that time, in fact, there have been some major extinction events that almost wiped out corals on Earth. The corals came back. But what happened in those events? It took, in one case, 18 million, and in the other case, 8 million years for those corals to come back. So I don't know about you, but I don't think I'm going to be around in 8 million years. So, we need to be thinking about what's going on human timescales. We're making major changes to the climate that's affecting all kinds of organisms, including corals. And the corals, while yes, they've been able to make adjustments over time, and in fact, some corals live in hot climates and some live in much cooler climates. The corals that live in the Arabian Gulf and the Persian Gulf experience really hot temperatures, much more so than those in Florida. And they've adapted to that because they've had time to adapt to it. And this gets into the whole problem. The problem is one of the rate of climate change. As CO2 and other heat trapping gases are going into the atmosphere, the change in temperature is going much faster than organisms are able to adapt, and much faster than many of our social systems have been able to adapt. As Catherine mentioned, we have already in the US and elsewhere climate refugees who have had to leave their homes, who have had to leave their communities because of the impact of climate change and other environmental impacts. So these are really important things we have to be considering, is the rapid rate that this is happening at. Continuing that question, number two was, if we emit a kilogram of CO2 today, over what time frame does that kilogram have its temperature effect? Is that effect more at the beginning of the time period or more toward the end? What percentage stays around for a long time? The answer is yes, more at the beginning than the end, although actually not right at the beginning. It takes a little while for that effect to be felt as it moves into the atmosphere. But carbon dioxide, Colin, last I've heard it's 200, 300 years on average for CO2 to last in the atmosphere.
This is a really hard question to answer because of the carbon cycle, which everything, all life on Earth is carbon based. So there's a lot of processes involving the element carbon. So some of the atmosphere, some of the carbon dioxide that we emit into the atmosphere can stay relatively short amount of time, say a couple decades, if it's quickly absorbed by the ocean. On the other hand, through much slower processes, it could be thousands of years. So it's really variable. It's really hard to tell, what percent stays around for that 2,000 years, especially because we're just continually adding more carbon dioxide, so it's hard to track. But yeah, so as long as that carbon dioxide is in the atmosphere, it can warm the planet and act as a greenhouse gas.
And you mentioned the impact of oceans absorbing CO2, also trees, vegetation. And one of the studies that just came out recently that talks about how these things are changing and how dynamic the cycle is, much of the Amazon, which used to be absorbing much more CO2 than was going out, much of the Amazon is now emitting more carbon than it's absorbing. And so we're seeing major sinks of carbon that are now turning and becoming sources in parts of the polar regions that used to be pulling in a lot of CO2 and pumping it into the ocean through biological processes. Those processes are slowing down. So that impact, as Colin was saying, it can last for various lengths of time. That time scale that each CO2 molecule is going to stick around is actually lengthening as we continue to change the environment. Alan Jenkins has a question. 1 degree Fahrenheit, we already see is disastrous, right? 1.5 or 2, even more so. And yet, how can humans limit Earth's heating to only 2 degrees or any set target, given that the climate is not static but dynamic, especially with positive feedback loops like Siberian bogs methane release or tundra methane release? You're absolutely right, Colin, Alan. It's a very complicated situation, and there are these feedback loops. I'll let Colin speak to a couple of those in a second. Actually, at this point, it's not 1 degree Fahrenheit. We've already warmed the atmosphere, the climate system, the global ocean atmosphere climate system, by over 1 degree Celsius at this point. We were significantly above that back in 2016 during really warm years. It's not quite as warm as it was in 2016, but it's close. And so we're past that point. What do you think, Colin? How can humans really influence the system and and make an attempt to stay within 2 degrees of warming?
The nice thing is that the science of global warming, like the study of radiation and physics, is really sound. So we know if we put a certain amount of carbon dioxide into the atmosphere, we know how much radiative effect that's going to have and how much that's going to warm the planet. And so when we run global climate models, those equations are really sound. Now, where we get into interpretation and areas of uncertainty is with what you're describing with different feedbacks. Another one that's really important is what's called the water vapor feedback. Warmer temperatures hold more water vapor. Water vapor, H2O gas, is actually arguably our most important greenhouse gas. It's not as widespread as carbon dioxide. Carbon dioxide can be high concentrations all around the globe, but of course warmer temperatures are more in the tropics, and so that's where the humidity is most of the time. But it's a much stronger greenhouse gas than carbon dioxide. But if you increase temperatures everywhere, you increase the amount of water vapor available in the air, and so it gets warmer. And then as it gets warmer, more water vapor gets warmer, and so forth. But there are also different negative feedbacks that we can also try and implement, like reforesting, where we're taking more and more carbon dioxide out of the atmosphere and sequestering it, draw temperatures down, so forth.
Thanks, Colin. That's it's also very important to remember that we got us into this situation. We can help get us out. Can we stay within 2 degrees? That's a really good question. I mean, personal opinion and opinion of a lot of scientists I've talked with, yeah, and Colin's shaking his head, is even if we do our best, we're going to overshoot 2 degrees. But the question is, in the long term, how long does it take us to get back underneath that and keep going? The real push at this point is not for 2 degrees, but 1.5 degrees of warming, because we have a large number of ecosystems that are going to be disastrously impacted by 1.5 degrees, coral reefs included. We have islands and entire countries that at 1.5 degrees of warming are going to be underwater. So these are things that we really need to be addressing and working as fast as we can on them. Joe's comment, we must also advocate that our corporations be responsible in their carbon footprints. And although we can recycle, but advocate for changing the use of, especially packaging plastic and oil-derived products. Joe, they're absolutely right. One of the biggest myths around is recycling. There is a lot of recycling that can be done quite well. Aluminum is the most recyclable product that we use commonly. Glass is fairly recyclable. Paper is fairly recyclable. Plastic is almost non-recycled. Even in places like the US, very little of the plastic you put in a recycling bin actually ends up going back into products. And at the same time, the oil companies, seeing what's going on with petroleum as a fuel, and same thing with gas, petroleum gas, natural gas, that they're seeking to make even more plastic for packaging for short-term use as an additional use for those products. We really need to be holding corporations' feet to the fire, and that's in fact one of the reasons why fossil-free PCUSA and presbyteries across our denomination have been working toward passing an overture to divest from fossil fuel companies, because a lot of money that our investments, our own Presbyterian Church's investments, are going into these companies. And by divesting, it sends a very strong message that we don't believe that these companies are working in our best interest.
And I'd like to add, as a consumer, we need to make the choice of purchasing a recycled product. Every piece of paper that we purchase to come in our house is made from recycled, but to try and find any recycled plastic, because all food products have to be made from virgin oil. So we need to also make that choice in our consumer habits.
Absolutely, Joe. That's a really good point. And I've been purchasing some products that are made with recycled plastic, but they're hard to find. It's really a tough one to find. And one of the things we do in our household, for example, is we always buy milk in paper cartons. And the paper cartons are actually much more recyclable and produce less waste than the plastic jugs that are so common. That's not a great solution, but yeah, it's one of the many things, the many little steps that we can make. Doug, he says, we must move from fossil fuels to renewable energy. Absolutely. There is waste with renewable energy that will be a large problem, as large a problem as CO2, unless we figure out how to deal with it. what is being done to recycle, reuse batteries, solar panels, and turbine blades. This is a good issue to address, and one that the renewable energy industries are addressing in saying, we know that there's a potential problem here. And as that grows, we're going to be addressing it, figuring out how to do it. There's a new process that's just been developed they're applying in Scotland, where they have actually figured out a way to completely reuse the materials in wind turbine blades when those are cycled out from use. Batteries, especially batteries in terms of the batteries used in cars, for example, when the lithium ion battery packs are no longer used in cars, those are being bought up very quickly to be used in renewable plus storage solutions, and in storage solutions for industries, where they're wanting to make sure that they have a constant energy source, and so they're using those batteries. They're not usable again in cars, or they may have gotten to the point that they're worn out enough that they don't meet the parameters that a car needs, but they're still extremely useful in those industries. And at the same time, there are companies that are working on what to do after it's gone through that second life, and that's how to recycle the batteries and turn them back into materials. Much of the lithium, for example, in batteries are now able to be recycled back into new batteries. Many of the other precious metals, the rare earth metals, that's the case as well. And so they're moving more and more toward making those batteries highly recyclable. But these are important things that we have to look at, because we have to make sure that the solution removes as many problems as possible. That was followed with a comment from Alan Jenkins. Doug, good question. And the environmental justice issues with extraction of Earth's minerals used in panels and the effect on watersheds. This is a really important one as well. I mean, there's no question that many of the minerals that are used, we need to make sure that these are being mined or extracted in renewable ways, and we're especially being conscious of the environmental justice issues. And Colin, this gets into some of your area as well, the effect on watersheds. A lot of these things use a lot of water, when at the same time we're dealing with more drought.
Yeah, absolutely. In fact, the Southwest California in particular has been suffering from a catastrophic drought over the last several years. And not sure how many of you saw the news, but Lake Mead, which is what the Hoover Dam dams for hydroelectric power, just reached a new minimum, so lowest level they've ever recorded. And they're very close to declaring the first water emergency in the history of the United States, which is a very, very big problem. And what do we do with that? We can't create water out of the air. It comes or it doesn't. It's a very big problem.
We're coming up on the end of our time. I'm not sure when we're going to be cut off, but we'll try to answer as many of the questions offline as we can. The question came up about agricultural methods, and someone responded about regenerative agriculture, which is a very important way of improving the way that our agricultural systems work. Also, the great move that has gone toward factory farms, toward intensive agriculture, especially for meat. The CAFO operations are extremely destructive, and moving back to eating locally and eating seasonally. You know, I don't have to have strawberries every month of the year. You know, I remember as a kid when the only time you got those really big beefsteak tomatoes was about August. And, you know, that was a great thing that time of year. And now we feel like we should have them all the time. There's a question, when we calculate future carbon production, are we including the immense carbon costs of the houses that need to be rebuilt, people who will replace their cars, et cetera, from climate disasters? Yeah, that's a real tough one. Colin, the impacts on human societies from climate change.
Yeah, absolutely. And to quickly answer your question, yes. In the latest global climate models from the latest IPCC report, Catherine mentioned Intergovernmental Panel on Climate Change, there is a new analysis, a new experiment that was done for these state-of-the-art climate models, and it's called Shared Socioeconomic Pathways. These are taking place of, if you're familiar with the term RCP, the representative concentration pathways from the last round of global climate model outputs. And these do, in fact, take into account all of these different societal impacts as well, from like building new housing because you've got to move away from the beach 100 yards or whatever. So yes, those are being taken into account. Are they perfect? Absolutely not. No global climate model is, but we've got a pretty good idea of how to account for that.
And we're seeing some great social comments coming in from Elizabeth Singley and Karen Kudaba. Yeah, I'll address this one sort of as a final before our plug gets pulled here. There are plenty of scientists who say it's too late to stop global warming and that our focus has to be on how we will face a totally different Earth. I wonder how our emphasis has to be. I wonder if our emphasis has to be how our Christian tradition informs our response versus Western science traditions. We tend to jump to tech solutions versus focus on, e.g., communal grieving as a way of generate heartfelt responses. These are really good points, and this is a very hard thing to deal with, but I'm among those scientists who have not given up. Yes, it's too late to stop a lot of the damage. A lot of the damage that's going to happen from climate change is already baked into the system. We've caused great changes already that are irreversible, but at the same time, we can do everything we can to keep it from getting any worse than it has to. And individual solutions versus large-scale solutions. This is why I wanted to make sure that we play that one video, the last one about what can I do, that Catherine Hayhoe talks about, not only individual solutions, but corporate solutions. Corporate in terms of the companies we support, corporate in terms of our governments, and the role that we need to be playing as voters, to be reaching out and making sure that whatever is being proposed is something that agrees with our Christian traditions, with our understanding of what Christ would have us do. And at the same time that we're doing that, we have to be looking at who's being affected the most, look at the issues of climate justice. We need to be looking at the fact that, yes, indeed, we are going to have to deal with adaptation at the same time as we're trying to deal with mitigation. Just because we're dealing with adaptation doesn't mean we're giving up, and it doesn't mean we have to. But it really is us looking at what we should be doing for the least of these, what we should be doing for the people who are most affected by climate change, and how we can make sure that the future that we choose is as equitable for everyone as possible. And that really has to start by looking at Black and Brown communities, indigenous communities within our own country, looking around the world at those countries that are still trying to develop their economies and do not have the resources to deal with things, while countries like our own have been among the major producers of the problem. So we need to be addressing all of that together. Colin, final thoughts along these lines?
Yeah, I think one of the things I like to talk about is that there's no one solution to climate change, and I think it's possible to get frustrated with that. Like with energy, we've had reliable, energy for 100 years, thanks to fossil fuels. But there's not going to be one thing that's going to fix that. Solar energy is incredible. There's more solar energy hits the face of the earth in one day than the entire United States uses in a year. It's a lot of energy. but it's not sunny everywhere, right? And hydroelectric is really great, but you're also disrupting an ecosystem. So it's really about cost benefit analysis and what's going to work best for an area. And that's what we're talking a little bit about. Eating more locally, producing more locally is, it's not a one size fits all thing for everybody. We've got to figure out how to see what's best for us in a specific area, and that's really hard.
Absolutely. And that's a good note to land it on. We really do have to be conscious, not just of, thinking about the science, but thinking about what we need to be doing, and being prayerful about what those solutions are and how we can be most equitable for everyone. So thank you all for being with us. We